Good morning, students. Hope you'll be fine at your respective places. Today, in continuation to this transport in plants, we are going to discuss diffusion, pressure deficit, which is simply a abbreviated form. It is DPD. So our main topic today is diffusion pressure deficit. Now, what do we mean by this diffusion pressure deficit? It means the amount by which the diffusion pressure of a solution is less than its pure solvent. So what I have written as the amount by which the diffusion pressure of a solution is less than its pure solvent. This diffusion pressure deficit is defined as the amount by which the diffusion pressure of a solution is less than its pure solvent. In order to understand it, I will take you the example. What we will see here, this is the semi-permeable membrane. Now, this is the chamber A, this is the chamber B. Now, in chamber A, we have got the pure solvent and it is the solution. Now, pure solvent, let it means water, so it is water potential will be maximum, that is 0, and it is solution, what we'll see, it is solute plus solvent, it is potential, water potential is less than 0, let it be -2. Now this pure solvent, it is consent, it is what to say, water potential is high, and that in the B, it is water potential is less, it is less than 0. So water will flow from A to B, that is from A to B, because potential, water potential of A is greater than that of B, or we can say the water will move from A to B because the concentration of pure solvent is greater than this solution. Now, what in this term, what we have to define the diffusion pressure deficit. Now, what is the pressure? What is the diffusion pressure? जो डिफ्यूजन प्रेशर इसका होना चाहिए, किसका? बी का, बाय विच द वाटर कैन मूव फ्रॉम बी टू ए. सो हाउ मच pressure, diffusion pressure, how much is it deficit, this B compartment, how much it is deficit, so that water will flow from B to A, because it is less than this A. Now there is a deficiency of this water potential, there is a deficiency in the diffusion pressure. So how much is it deficit, so that this water will flow from A to B. Now this, what we call as diffusion pressure deficit, it is, अगर हम इसको इक्वेशन के जरिए भी दिखाएंगे, इट इज इक्वल टू OP, ऑस्मोटिक प्रेशर माइनस वॉल प्रेशर, विच इज ऑल्सो कॉल्ड एज टर्जिड प्रेशर. अब हमारे पास एक इक्वेशन आ गई, DPD, diffusion pressure deficient, it is equal to osmotic pressure minus what we call as a wall pressure. This is osmotic pressure and this is wall pressure and this is turgid pressure. Now I will proceed further. क्या अब मैं और प्रोसीड चला जाऊंगा क्या हाउ आई विल शो दिस कि मैं आपको ये भी दिखाऊंगा व्हाट डू वी मीन बाय दिस वाटर पोटेंशियल और व्हाट डू वी मीन बाय दिस व्हाट वी कॉल एज दिस टर्गर प्रेशर. Suppose this is the cell. Now the water molecules, they start to move from outward towards the inner side. So जो एक्सेस पानी इसमें चला जाता है, जो एक्सेस पानी इस सेल के अंदर चला जाता है, that water molecules, they exert pressure on the walls of this cell. For example, this is the water molecule. This water molecule, it exerts the pressure on the walls of this cell. So this is called as the turgid pressure. This is called as the turgid pressure. Now, this wall in its turn, it also exerts pressure on this water molecule, but in the opposite direction. This wall, in its turn, it exerts the equal but opposite pressure on this, what we call as the water molecule, and that pressure is called as the wall pressure. This pressure which has been exerted by this new water molecule which enters into this cell, it exerts the pressure on this wall, that is called as the turgid pressure, and this wall in its turn, it exerts equal but opposite pressure on this water molecule, that is called as the wall pressure. So this wall pressure, it is also called as the turgid pressure. Now we have got some situations where we can calculate this diffusion pressure deficit. For example, in case of the turgid cell, अब हम एक turgid cell लेंगे. In the turgid cell, we have got the osmotic pressure. It is 10 atmospheres. Since it is turgid, water has जो turgid है, it is turgid cell, so it means it has got some turgid pressure. It has got its maximum turgid pressure. Let it be 10 atmosphere. So जो हमारे पास dpd आ जाएगा, it will equal to osmotic pressure minus turgid pressure. It will become to 10 minus 10, that is equal to 0. Now second condition, we have got flaccid cell. Flaccid cell taking these units same. For example, we have got osmotic pressure, let it be 10 atmospheric units, and turgid pressure, since the water has water expels out of this flaccid cell, so this turgid pressure, it will be equal to 0. So dpd, it is equal to op minus turgid pressure, that is equal to 10 minus 0, that is equal to 10. Now condition arise. Again, we have got two cells. This is the first cell, this is the second cell. This is the turgid cell. I may write this with this is the turgid cell, this is the flaccid cell. अब इसका जो हम देखते हैं turgid pressure जो है, that is, या अगर हम इसका dpd देखेंगे, हम dpd देखेंगे, that is equal to 0, and अगर हम इसका dpd देखेंगे, it is equal to 10. Now we will see that water will move from lower this diffusion pressure deficient to this higher diffusion pressure deficient. Now we have got two cells. They are separated by this semi-permeable membrane. One of them cell is turgid, another one is flaccid. एक सेल का डिफ्यूजन प्रेशर डिफिशिएंट इज 0 एंड दूसरे सेल का डिफ्यूजन प्रेशर डिफिशिएंट इज इक्वल टू 10. वी विल सी द वाटर होगा, इट विल फ्लो फ्रॉम lower this diffusion pressure deficit to the higher diffusion pressure deficit. हाँ, अगर हम इस कैलकुलेशन में देखेंगे जहां पर टर्गर प्रेशर ज्यादा होगा, टर्गर प्रेशर ज्यादा होगा या टर्जिड प्रेशर ज्यादा होगा, वहां से भी हम देखेंगे उसका जो वाटर पोटेंशियल वो ज्यादा होगा. सो वाटर, अगेन इफ वी चेक दिस, द वाटर विल फ्लो फ्रॉम दिस turgid cell towards this flaccid cell. So what we will see, so we can conclude this, when the two cells they are separated by means of a semi-permeable membrane. One cell have got the low diffusion pressure deficit, another one has got the higher diffusion pressure deficit. So the water will move from lower diffusion pressure deficit to the higher diffusion pressure deficit. Now we have got, now let us try to solve another this example. We have got two cells. One cell is A, another cell we have got B. Now we have got this, एक सेल का osmotic pressure that is equal to 10 atmospheric units and its TP is, that the turgid pressure is equal to 6 atmospheres. So what will be the dpd? Dpd is equal to OP minus TP, that is equal to 10 minus 6, that is equal to 4. Now take the case of another cell. इसका भी हम देखते हैं कि OP that is equal to 10 atmospheres, turgid pressure that is equal to 4 atmospheres. And now what will be the dpd? Dpd will equal to OP minus TP, that is equal to 10 minus 4, that is equal to 6. So what will be the flow of water, कि पानी कहां से कहां चला जाएगा? So we will see that, we know that, अगर हम इसकी कैलकुलेशन देखेंगे, what we will see कि जो पानी जो होगा, it will flow from, water will flow from lower dpd to higher dpd. Now in case of cell A, it has got lower dpd, and this B cell it has got higher dpd. So water will flow from cell A towards this cell B. Now cross check कर लो, turgid and this turgid pressure, that means इसका water potential ज्यादा होगा, that means the water will flow from higher water potential to the lower water potential. एक और एग्जाम्पल हम कोशिश कर लेंगे. We have got two cells. एक cell, let it is C, and we have got another cell that is D. Now इसका जो OP है, osmotic pressure, that is 10 atmospheres, and it is turgid pressure जो है, that is equal to 6 atmospheres. Now what will be the dpd? Dpd is equal to OP minus TP, that is equal to 10 minus 6, that is equal to 4. Now in another case, cell B, what we will see, OP is equal to 10 atmospheres, and in the second case what will be the turgid pressure जो हमारे पास है, that again is 6 atmospheres. Now dpd is equal to OP minus TP, that is equal to, हाँ एक मिनट यहाँ पर हम क्या देखेंगे कि थोड़ा बहुत उसको और हम, it is 8. Now what will happen? 8 minus 6, that is equal to 2. Now we know कि जो water होगा it will start moving from the what we will see. अब यहाँ पर जो होगा सेल C और सेल D में what we will see the conditions. अब इसका DPD it is 4, इसका DPD हम क्या देखेंगे? It has got what we call as a 2. Now both of them have got the turgor pressure same. In the first instance what we will see, or DPD, there is 4 and there is DPD 2 only. So what we will see, जो water due to this, the water will flow from D to C, because जो diffusion pressure deficient है it will flow from, जो C है it has got less DPD as compared to that of D, so water will flow from, no sorry, D has less as compared to that of the C, so water will flow from D to C. Again, what we will see here, when the DPD pressure will become equal, जब DPD pressure बराबर आ जाएगा, then we will see no net movement of the water will take place. When हम ये देखेंगे, when this DPD pressure will become equal, then we will see no net movement of the water will take place. This was about this DPD. So if we recapitulate, what do we mean by the DPD? DPD simply is the amount by which the diffusion pressure of a solution is less than that it is pure solvent. So what we will see, we have given some examples, we have made some calculations here, and we come into conclusion that the water will flow from low diffusion pressure deficient to the higher diffusion pressure deficient until an equilibrium is maintained. When equilibrium is maintained, no net flow of water will take place. This was all about this topic. In the next topic, in the next lesson, we will try to discuss further what do this continuation of this diffusion, this transporting plants. Until then, goodbye. God bless you. Thanks.